Hello, it's Keith here, and this is lesson 41 of the platform-specific series of my 6502 assembly programming tutorials. We're on the Super Nintendo once again, and we're going to be looking at the tile map. Now, we used the tile map before in the platform-specific and simple series to draw a Chibico bitmap onto the screen using tiles, and you can see above me and over to the right in the animated GIF, we have those Chibico bitmaps once again, but there are now more than one of them, and we have a third bitmap. You see, we're using multiple tile maps this time for multiple layers, and then we are scrolling some of those layers around, which is why you can see some bits are moving. So we're going to be looking at this example. It's an extended version of the simple series version. We're turning on three tile maps this time. We're defining them all and moving them all around. So that's what we're going to be doing. Now let's go over to the source code. Let's take a look at what we've got today. Okay, so this is the example code we're going to be looking at today. We're not going to really be discussing the basics, so if you've not seen the simple series example of the bitmap, please take a look at that, because I'm going to be rushing over that kind of thing. I'm here showing you today how to extend and use multiple tile maps, not how to get a single tile map working, because we'd just be recovering all the ground we'd covered before. So the first thing we're going to do is we're going to specify the address that holds the patterns for our characters, our Chibicos and our new character, the Raider there. So we're going to be moving the bitmaps into those VRAM addresses, but we need to specify to the tile maps what memory address to use for the pattern data. And we're going to specify that all four tile maps use the same address, and we're going to use word address 2000. Now we're actually only using three tile maps, and I'll explain why in just a moment, but basically to define these we're using 210B and 210C, and these are memory mapped video registers basically. So each of these is specified by 4 bits, and the 4-bit value that we specify is effectively multiplied by 2000 in bytes or 1000 in words to specify the eventual VRAM address being used. So we're going to be using memory address 2000 here for our pattern data for our tile maps. So we're specifying both of those here. And then what we need to do next is we need to specify the VRAM address of the actual tile maps. So we only need 3 tile maps, and the reason we only need 3 is the number of tile maps depends on the configuration of them. My understanding is that the only way to have all 4 tile maps is if they're all 4 colors. So what we've done is we've got 2 16 color tile maps, and the 16 color graphics, you wouldn't know, but they're actually the Chibicos. And the 4 color tile map is this character here. This is Raider here. So that's why we've got these different characters on screen, because the 2 Chibicos are 16 color layers and the other character is the 1 4 color layer, and that is, I believe, the most layers we can have. If we've got 16 color layers, we can have, I think, 2 256 color layers or 4 4 color layers, but this is, I think, the most beneficial. But that's partially because I'm a multi-platform programmer, and 2 layers is pretty much all you're used to having, so that's what I've decided to choose here. Anyway, we need to specify different VRAM addresses for the tile maps, otherwise if they had all the same address, they'd all show the same tiles, which wouldn't be so good. So what we're doing is we're defining the tile maps as being 32 by 32 tiles, which is probably a little small, but more than enough for this example. And we're going to specify the memory addresses 0, 400, 8 and 800 for the 3 tile maps. And so basically we have to use the bits from 2 onwards in ports 2107, 2108, and 2109. We have to write the bits accordingly, and these are basically multiplied by 800 in bytes or 400 in words. So we're specifying tile map addresses 0, 400 and 800 with these bit combinations here, and then all we need to do is write our tile numbers to that area, and that will appear as tiles on the screen. We are then just needing to define the tile sizes here. We're just defining these all as 8 by 8 tiles, and then we are just turning off the screen while we set things up. Now we're setting up our palette, and we're just setting up 4 colors, which is part of the reason why, even though we've got all of these tiles, they all look the same colors. Maybe it would have been nice if this was a 16 color example, but I didn't really, unfortunately, have time to redo all of the graphics for it, so I apologize that we're only seeing 4 colors on the screen here. We're then setting up some initial scroll positions for the tile maps. We'll discuss that more later on. And we're clearing all the tile maps, and I've created this new clear tile map function, which is just basically clearing 32 by 32 tiles from the base address specified. So 000 there, 400 and 800 are the 3 tile maps. We're then defining our bitmaps. We've got our 16 color Chibico bitmap. It is 16 colors, even though it only looks like it has 4. And we're writing that to memory address 2800. That's a word address in VRAM. We're using the define tiles function we used last time. So that's just transferring our bitmap that we've specified to VRAM. Now, that is effectively tile number 128, 2800. Now, tile number 128 in 16 color tiles. I say that that's a bit odd, but we'll get to that in a moment. We're also transferring our 4 color character. That's the radar character. That's this one here. And we are specifying the memory address of the bitmap data to transfer. That was exported with AccuSprite Editor. All of my sprites are exported with my AccuSprite Editor. It's free and open source. It's included in the download. And that is being transferred to VRAM address 2400. Our original one was written to 2800. Now, our original one was at tile 128 on the 16 color tile map, and that's because each tile is 32 bytes. 2400 is also at tile 128 because on the 4 color tile map, each tile only uses 16 bytes. So it's at a different address, but it's at the same tile number because the tiles use half the memory. It seems a bit weird, but it all works out if you think it through. But as I say, it looks a bit baffling when you see it. Anyway, once we've defined our tile maps, we then need to turn on the screen. We're turning on the 3 tile maps here, and then we are enabling the screen here. And then what we're doing is we are using the fill area with tiles function we wrote before. We're defining an area, a tile number 128 in both cases. All we've added now is a new tilemap base entry in the 0 page. That's a defined 0 page entry. And Chibico 1 is going to the tilemap at quadruple 0. Chibico 2 is going to the tilemap at 400. And the 4 color radar character is going to tilemap 3 at 800 in VRAM. So we're specifying a different tilemap base in all those cases. And the way I've written to a different tilemap, very straightforward. All I've done is I've nobbled the get VDP screen pos function. I've tweaked it a little bit, and I'm adding the tilemap base to the high byte of the calculation and the address selection. And as I say, if you don't know how these things work, selecting VRAM addresses, writing data to VRAM, please see the simple series, because as I say, I've been over that in great detail there. And if you don't know how to get a tile on the screen, then you shouldn't be worrying about how to get multiple tilemaps on the screen and scrolling them, because that's more advanced. So yeah, please take a look at that if you need help on that. So that's how we've got our tile maps onto the screen. How about scrolling them? Well, we scroll them. It's very straightforward. All we've got is we've got these memory mapped video registers here. So 210D is the X position of the first tile map. 210E is the Y position of the first tile map. 210F is the X position of the second tile map. 2110 is the Y position of the second tile map, and so on for the third, and if we had it, the fourth tile maps. So basically I've remmed out some of these so that we had some nice interesting scrolling here. You know, we've got these moving over the top of each other so we can see how they layer. But of course, if you just change the remming here, you could change which one scroll. And the fact that the third tile map isn't scrolling isn't a forced option. We can scroll it if we want. It's up to us. So we've got all of that functionality there. The only thing that's slightly odd about these is we have to write 2 bytes to each of these addresses. The first byte is a low byte and the second byte is a high byte. So effectively we're specifying 16-bit addresses for the X and Y scroll, although actually I'm just writing a 0 for the high byte in each case. So it's good enough for this example, but it was basically just because I'm using 2 1-byte values and I'm altering them, the X and Y values, and then I'm writing them to these video registers here to affect the scrolling. But anyway, there we go. That's what we are covering today. That's the end of it. As always, you can go to my website and download the source code, and you can have a go with this yourself and have some fun with it, hopefully. If you've liked what you've seen today, please hit the like button and subscribe. If you like the videos, YouTube recommends them to more people, and if you subscribe, it makes me very happy, and I might make some more videos someday. I am going to, I'm only joking. Hopefully we're going to be covering the window, and also there's some special effects that the Super Nintendo can do with regards to changing colours and things. So as soon as I figure out how to do them, we'll be covering those as well. I do also, of course, have 65816 and 6502 tutorials, and if you want to know more 6502 and and support this channel, you can buy my book. It's called Learn Multi-Platform Assembly with Chibi Akamas, and it covers Z80, 6502, 68000, 8086 and ARM. It doesn't cover 65816 yet, but if it's popular enough, I will write a following book which will. So please consider doing that if you want to see more content. Anyway, I hope you've enjoyed this today. Thanks for watching today, and goodbye.